Hey everyone, welcome back to the channel. If you've looked at some of my previous videos around shell scripting, you know that I like to just take the basics, build a simple script on it, and add something new. In previous videos we covered stuff like arrays, variables, functions, conditional statements, while loops, and today we're going to add a couple of new things. Today we're going to take a look at APIs and we're going to take a look at JSON. So we're going to build a script using both of these, but we're not going to build something too complicated. So if you haven't seen the previous videos, you should get along quite easy. Nothing too complicated here. So the API we're going to use here is on the screen. You can see it's called Geocoding API. It's a very simple API where you type in the name of a city, B-B-L-I-N, because I'm in Ireland, and you get some general information about that city, including the longitude and latitude, population, and then you've got these other columns as well. The website is openmeteo.com. There's lots of free APIs on this one. For personal use, you can do up to 10,000 calls a day, so it's fine. I mean, we can use this then for learning. You can see here that it gives you the full URL for the API, which we will use later on. The important bit to note here is the Dublin section, because we will have to change that. And the API documentation then talks about this is the API that needs to be, this is the API data that needs to be sent. And we see an example result in JSON format. We'll talk a bit more about JSON in a few minutes. And then you see all the different parameters that comes back. Oh, sorry, hang on a second. Yeah. So this is what you send. And this is what you go back. I'm not going to go through the documentation here. I'll leave a link in the description below. You can check all this out. Okay, so let's get into some coding. First of all, this is a bash script. So we have to let the system know it's a bash script by doing hash bang bin bash. And because it's Vim, I will just save and exit. You can use VS Code for this. I like to use Vim. I've been using it a long time. But VS Code, Notepad, you know, there's lots of different tools you can use here. So, but Vim is my personal favorite. If I reload Vim, then Vim sees the hash bang at the beginning and it knows exactly this is a shell script, and then we'll do the syntax accordingly. Okay, so we're going to create a couple of different functions here. We're going to create first one called fetch, if you fetch API data. So this is going to be basically a curl command that will pull down the different API data that we need. Curl is quite useful. I mean, you can use it to download a web page. In this case, we're going to use it to pull an API. One thing about curl, though, if it's pulling a large amount of data, it tends to give you some results like, you know, how big it was, how long it took. We don't want any of that, so we use the -s option. And the -s option is for silent. So let's put our API data in. So we go back to our page. We find the URL. We copy back to the page, and let's just paste it in. Okay, so this is our function for pulling the API data. The next function we will create will be to display the data, because if you see in the demo, you can see that the JSON form, the JSON itself is not necessarily what we want. I mean, maybe we just want a certain feature, certain key values out of it, and we need to display it as we want. So this is actually fetch is the wrong name. Display API data, and we'll just say echo $1 here, just so it's not empty for now. And then our last function of the tree will be main. The main function is where obviously our main code is run. So again, we'll do echo $1. And we will add our curly brackets, and then at the end we will run our main function. We'll call our main function, and we're going to call our main function with a special parameter. So this is the $@ parameter. This is a special parameter that contains all of the arguments that was provided to the script when it was run. Best way is to give you an example. So if we go into the main function itself, we change that to that. And then we say the first argument from the command line is going to be called $1. Second one is going to be called $2. The command line itself can also be gotten if you use $0. So $0 will contain the command, $1 will contain the first argument, $2 the second argument, so on and so forth. And $@ contains all the arguments. So let's just give you a look. Okay, so we do bash get geo info page, and then say arg1, arg2. And if we run that, we can see So the first one is the $@, so that's all the arguments that was provided. Second one is $1, that's the first one. Third one is, second one is $2, and then argument 2, and then you got the command itself, which is $0. So this is how you pass arguments from the command line into the program and then distribute those arguments throughout all the different functions, okay? So let's go back to our script. Okay, so let's go into the main function here. So what we want to do is our first command line argument is going to be the city. So what we're going to do here is we're going to create a local variable. It's called city, and we'll call that equivalent to $1, which will be the first argument of the script, and it will be passed in via this array here. I'm not sure if this is an array, but anyway, special variable. And then we want to do our fetch underscore API underscore, underscore data. And then we're going to use our city variable, so our city. Okay, so this function is going to pull our data. Now the thing is, the URL as we copied it directly from the web page will not do. So we need to create a custom variable. So let's say we create a local variable up here called city, and again it takes the first argument coming into the function, which will be provided via this command here. Okay, now we've got to make sure that we change the section here. So remember I copied it and it had the city I was looking for, Dublin. So I'm not that interested in that, so I'm going to put in my variable. Now you might say to yourself, why the curly brackets? Well, the curly brackets are so when Bash is interpreting the URL that it doesn't get confused, and it starts adding these extra characters as part of the variable name. So these curly brackets just make it clean, so it knows that this curly bracket contains the full variable name, not to get confused. Also worth mentioning is why we use brackets all the time with variables. If you take a look at this URL, it's got ampersands in it. Now Bash interprets ampersands on the command line as a special character. Okay, so there's lots of special characters in Bash, and if you didn't wrap this up in quotes, you would just confuse the script. So curl would only really work up as far as the first ampersand, and then it would just misbehave. So better off wrapping them all up in quotes. Okay, so next, I think we're good to go. We should just run it and see what happens. So it should be in our history. Ah, you see, that's not a proper name. So let's put in Dublin. Let's see what we get. Yeah, it worked. Okay, great. I'm surprised it worked in first go. So what have we got here? We've got the JSON, but it's not really printed out that nicely. I mean, what is JSON first of all? So JSON is JavaScript Object Notation. It's supposed to be a lightweight data format used for storing and exchanging information. It's supposed to be human readable and easy for machines to parse. This doesn't look very easy for machines to parse. This doesn't look very easy for humans to read. But we can make it easier to read because Linux has a command line or a command called JQ. Now you have to install this command. It doesn't come with most distributions by default. So on Ubuntu, you would do apt install JQ. Now when you pipe the output of our script, which has the JSON into JQ, which is it's like a JSON query tool, it prints it out pretty. So now we got pretty JSON, and it's much easier to read. So JSON contains two special structures, right? You've got objects, which are always wrapped in curly brackets, which are key value pairs. So it means when something is wrapped in a curly bracket, it always has a key, and then a key has a value. And then the other structure type is arrays. Arrays are always wrapped in square brackets, and arrays are just lists. So in this case, we have a curly bracket, and then we have a key value, we have a key, which is results. And the value of results is actually an array. And when we look inside the array, we see that there's an object inside there. So you can have a list of objects inside of arrays. So it's a very high level overview of JSON. I'm definitely spend some time. JSON is very important when it comes to the internet. Most APIs are using JSON, and it's definitely worth spending a bit of time learning about it. But that's as far as I'm going to go with it. Okay, so let's go back to our script. Actually, before we go back to our script, let's talk more about the JQ command. So JQ on its own takes the JSON that's coming in and just formats it pretty. This is the equivalent of just typing a full stop inside single quotes. It's the exact same thing. But the thing to note here is you're able to browse the JSON. So for example, if I just type results, now because results contains a list, list items always have index numbers. So the first item in the list is going to be a 0, second one is a 1, third one is a 2. Now because our example only has 1, it's going to be the first one. And in this case, it's going to be 0. It's always the first one is always 0 in an array. And then if we print that out, we see that it's suddenly this part is gone, and we're inside the first list item on the array. Now, all of these key values are also browsable. So say, for example, I wanted the country. Again, I can just do another stop and just type in the word country, and I get the country. And last but not least, we like to control the quotes, and I want to remove these quotes. So JQ offers the -raw option, which basically removes the quote. So now we get it in pure text. Okay, or a string, whatever you want to call it. Okay, so this is really useful for our display section. So let's copy this, and let's edit our file again. Okay, so if we go into the display section of our script, so before we start with the display API data, we need to clean up our main section. So we need to pass the results of fetch API data into our display API data. And we do this with command substitution. You can create a simple command substitution by just wrapping something up in a $sign and some brackets. Now, what is command substitution? It allows for the output of a command to be used as an argument for another command, or in what we're going to do, as it allows it to be assigned to a variable. So in this case, we're going to assign it to geodata equals. And we're going to create a local variable with that, because we're not going to share this with other variables. Or sorry, we're not going to share this with other functions. And then we take our new variable and we do display API data, and we just send the value of our new variable. So now we're in our new variable, and again we're going to use command substitution here. Okay, so we're going to create another local variable here, local, and we're going to call this one, say, just API data equals $1. Okay, wrap it up in quotes in case there's something funny going on. So now we have a local API data variable, and we're going to get our country. So we're going to create another variable called COUN country, and that equals, and now we're going to do command substitution again to pull out. We're going to run a command, and that command is going to produce data that's going to be assigned as the into the variable country. So we're going to basically echo the API data variable. Sorry, I made a right mess of that. And we're going to pipe that into our command from previous. So we're going to cat out the API data. We're going to pipe it into the command we did earlier on. So I mean, this is pretty much exactly what we just did on the command line, okay? And then we're just going to go echo and see if it worked. So basically, when our main runs, it assigns our first argument is city1, runs the runs the fetch API and assigns it into geodata, and then we try and print out something. So in this case, we're printing out the country. Okay, so let's take a look. And we're going to move all of this gobbledygook, and yeah, got the country, Ireland. So if we change this to, say, London, United Kingdom. So far, so good. It's working pretty well. A very simple script, doesn't do much, but it's just to kind of introduce you to the concept. So let's take a few more things, right? So let's say we want the longitude. And again, there was a longitude value in the API, longitude. And let's say we take latitude. And we change this with latitude. And what else have we got? Sorry, it's a typo. And let's say we take name. I remember the name, let me just double check actually. Let's just take a look at our API data. So yeah, so the name was the name. So the key of name at the value of the city. Okay. So let's just double check that. So name equals name. Okay, that's pretty good. And we're going to just say echo dollar long. Whoops, dollar, not pound. Put in a nice comma here. Okay, so now I hope this is all you're following along here. So now we should be able to print out the country, the longitude, the latitude, and the name. Let's see if this works. So we've got the country right, we've got the longitude right, we're missing the latitude, and we've got the name right. So I presume it's a typo, or I spelled something wrong. Oh yeah, of course, 2 I's in latitude. Yeah, and okay, so now we've got United Kingdom, we've got longitude, we've got latitude, and we've got London. And we can easily test this, so we can just copy the longitude and latitude. And we can go into, say, maps.google.com. And we can say, well, let's scroll out because I mean it's automatically defaulted to my home country here. So let's move over here somewhere to the middle of China. Scroll in. Okay, so let's put in our longitude and latitude. See what happens. Oh, what? Okay, I must have mixed it up. Okay, so that's good. That's good. That's good. So let's change the script. Let's modify the script so it's the other way around. So let's put in dollar longitude, and we'll delete the other one. Okay. Now we run our script again. We get latitude and longitude. Copy. Back to our page. Stick it in. That didn't look right. Now it looks better. And where does this bring us to? Should bring us to London. Yes, London, Trafalgar Square. Perfect. So, yeah, it works. Okay, so you can pull the longitude and latitude out of this API pretty quickly. I mean, you can modify this script a lot yourself. I think there might be a bug in it. So if I put in something like New York, what happens? So it reads the first bit and picks up this new thing, and there's some city in Nigeria, but that's not what we want. Maybe, like I mentioned before about the quotes, I always wrap it up with quotes. No, didn't like the quotes either. So let's go back to our API page for one moment. And let's go back up. And what happens if we put in New York here? York. So it works. And let's take a look at the API. Okay, so New York puts a plus sign instead of a space. So let's try that with our script. Let's modify it slightly. So where can we do this? We could probably do it here. We could probably introduce some command substitution here. So we could put in, let's say echo. And let's say we could pipe that into, so there's a command called tr in Linux, which is I think it means translate. And that allows us to translate one character in a string to another. So we can just do plus. So in theory, that should find all the spaces inside our string and just convert them to pluses. So let's try it again. Oh, Okay, so United States, longitude, latitude, and let's try this in Google Maps, see what happens. Let's go into maps.google.com, paste it in, see where it brings us. Yay, it brings us to New York, yay. So that works, that's pretty good. And is there anything else we can do? Just to finish it off. Okay, we want to make sure that if there is no arguments provided, that it triggers an error. So that's quite simple. So what we can do is we can create a conditional statement. So we can do if minus z, actually it's not, it's if not minus z $1, then. So this is the exclamation mark, and in Bash this means not. This minus z means has it a 0 value? I mean, is it empty? So pretty much this says if not empty $1, which is our first argument, then we can do this. We can actually run our script. And just tidy it up a bit. And then we can do, and then else we go echo, and then usage. Now, if you remember from earlier, our $0 means the command itself, and then we can just put in square brackets city. So let's, oh, you got to close off the conditional statement. So if the value is not 0, then we can set up our city, run our fetch API, and then display the output. Else, we're going to just echo the usage and end the program. Let's try it out. So this is New York. It works. We missed something in our script. What did we miss? We missed the quotes, I believe. Yeah, we missed the quotes around the $. See, this is what I told you. You've got to check those quotes, otherwise things won't work as expected. So that's it. That's all I've got. I mean, feel free to play around with this. I'll leave the code up on GitHub. It's very basic stuff. I mean, it's not that complicated. You should be able to figure it out yourself and play around with the website. I mean, it's got lots of other APIs on it. We might do another video on maybe the weather one. And yeah, so my name is Tom Kraz. I hope you got some value from this. If you did, please like and subscribe, and I'll talk to you all later. Okay, take it easy. Bye-bye.